Hello everyone, welcome to our channel EduMoon tutorial. I am Keerthana and in today's class we are going to discuss on the most important topic and frequently asked topic from chapter 2, that is collision free protocols. So let's get started without any further delay. What are collision free protocols? Although collision do not occur with CSMA and collision detection protocol, there are few disadvantages in this algorithm. When the bandwidth delay product is large and frames are short, the collision affects the system's performance. So CSMA and CD is not universally applicable. To overcome collision, let's discuss some protocols. First one is BITMAP protocol. Here there are n stations and each have a unique address from 0 to n-1 and the contention period is equally divided into n slots. For example, if the station 0 wants to send the data, it can only send in the 0th slot, and during that time no other stations can allow to send the data. Here if the station 1 wants to send, so it is represented by 1 represents the transmission. So in the next stage the 1 transmits the data, and then if in the third period if the slot 3 wants to send the data, it sends the data. Like that all the stations in a queue will start transmitting the data. This protocol is like reservation protocol. So it is also known as a reservation protocol, where the channels are reserved in advance. This helps to prevent the collision. Next, coming to token passing, and it's another way to reduce collision. Here we use tokens, which is a small message helps to pass from one station to another station, and it is in the form of the circular manner. This follows circular topology, and the token represents a permission to send the data from one station to another. And if the station has a frame queue for transmission, when it receives the token, it can send that frame, and after the transmission, it passes the token to the another station. In this way, in a circular manner, the protocol continues. Next is a binary countdown. Here, all stations are assigned a fixed length binary addressing, which consists of zeros and ones. For example, here there are 4 different stations, and the first bit of all stations are as follows, that is 0, 0, 1, 1. Now here we have to check the which is greater, like 0 is less whereas 1 is greater. So these 2 stations will be considered or allowed for the transmission. And next time slots, these 2 stations second bit will be checked, which is 0, so it shifts. It compares the next bit. Here, whereas the station 1001, the next bit is 0, and for 1010 it is 1. So this will be the winner. This gets the chance to transmit the signal first, and the process follows until all the stations get the chance to transmit the data. Next is limited contention protocol. Here it combines the best properties of contention protocol and collision free protocol. Contention provides low load and low delay, whereas collision free provides high load and provides channel efficiency. In this, there is an adaptive tree walk protocol. Now let's see what is this. Here there are stations which are divided in the form of a tree based, which consists of this is level 0, this is 1, and it is divided in the form of levels. In the beginning, everyone is allowed to compete. Then if a collision occurs in the group, then then only the nodes or stations in group 1 are allowed to transmit the data. And again, if in node 2, if 4 and 5 wants to transmit the data, they'll transmit. Again, if between these both the collision occurs, then 4 will transmit the data. Like that, the process continues until all nodes transmit the data. Now coming to the important topic, wireless LAN protocols. Here there are two problems. First one is hidden station problem and next one is the exposed station problem. Suppose there is a terminal A and this is the coverage area for A. This is the coverage area for A. And let's consider the terminal C, and the coverage area for the terminal C is this. If we observe keenly, the coverage area of A and C are undisturbed. And so now let's consider a different case where B is in between the both of the coverage areas. That is, B have access of coverage area of A as well as coverage area of C. Now the problem arises when both A and C wants to send the data to B, then a problem arises. Now let's see what's the problem. As C is not in the coverage area of A, C don't know that A is transmitting the data to B, whereas A also don't know that C is transmitting the data to B. So when they both transmit the data at the same time, they will collide at the station B. This causes collision. This collision occurs due to the hidden terminal problem. Here A and C are considered to be the hidden terminal to each other. This problem occurs as A and C are unaware of each other's transmission and the radio range of each other are different and are far from each other. So A and C are said to be hidden nodes with respect to each other. Now let's see a different scenario where B is transmitting the data to node A. Then node C is aware of the transmission as it is in the same coverage range as that of the B, which is the blue color region. And at the same time, when C wants to transmit the data to D, it first senses the medium. It sees B's signal. As it is in the same coverage range of B, it will not transmit to D, thinking that B is sending data to C. So here actually the tree's transmission to D is not at all a problem, as our coverage range of D and A are different, and the transmission from C to D will not at all interfere the transmission from B to A. Here C mistakenly concludes the conversation it hears from B, which is intended to A and cannot send to anybody. This causes exposed terminal problems. So the solution here is MACA, that is known as multiple access with collision avoidance. For example, A wants to send a frame to B. So A starts, that is the sender, starts transmit an RTS signal, which is request to send frame. Then the receiver, which is B, replies with a CTS, which is known as clear to send frame. This RTS, it includes how long the sender wants to hold the medium, which is also known as the length of the data to be transmitted. Let us consider this example. Here in first figure you can clearly see that A is sending the signal RTS, and in the second figure the B is replying the signal frame with CTS. Any station close to A hears the RTS, but it does not senses the CTS frame. Here for example, C senses RTS as it is in the range of A, but it does not sense the CTS as it is not in the range of B. So here CTS waits for some amount of time until the transmission is completed and then sends data to F if C wants to send data. The same case is near D. The D senses the CTS signal but does not senses the RTS signal as it is close to the receiver. So it cannot transmit the data for a particular amount of time, and then after some period amount of time it transmits the data. Whereas here the E senses the both RTS and the CTS. Here its E silently waits for a particular amount of time until the transmission is completed, and then it sends the data. I hope everyone understood the concepts. If you have any doubts, please comment in the comment section. Thank you for watching.